Welcome to the Polar Steam Cool Connections live stream. While we're waiting for folks to join, please post in the chat where you are watching from. And if others are joining you, perhaps from a summer camp, perhaps school classes have started and you're watching from a class, we'd love to know, and we'd love for you to share how many people are watching from your location. Okay, we're going to go ahead and get started. I'm Jamie Ivory, the Logistics Coordinator for Polar Steam Program, and we are excited to have you with us today. Polar Steam is a U.S. NSF-funded program based at Oregon State University that facilitates virtual and field-based collaborations between polar researchers, educators, and artists to enhance science communication, bringing polar science to everyone. A recording of this live stream will be posted on our YouTube channel. We will keep the focus of today's event on this team's stories and experiences understanding the North Atlantic currents. However, I will mention that while applications for the Polar Steam Antarctic Artists and Writers Program and the Educator Program have closed, we are currently looking for NSF-funded polar researchers that want to collaborate with an educator or artist in 2027. We also would like to invite you to join us at the Polar Steam Summit, where polar science, art, and education intersect and curiosity comes to life. This is an in-person event held in Corvallis, Oregon, October 1 through 3. We still have registration open, and we would love for you to join us. We welcome researchers, artists, educators, and everyone that's interested in polar science. All right, now live from the research vessel Neil Armstrong in the Labrador Sea, we're excited to connect with two of our Polar Steam Fellows, Margaret Lindeman and Kathleen Fuller, taking a short break from fieldwork to join us all today. We will start with a presentation from the fellows and follow that with questions from all of you, our viewers. You can submit your questions live in the chat. Our team will monitor those questions and those questions that were submitted ahead of time there. I'd like to introduce to you our fellows. Margaret Lindeman is a physical oceanographer at Harvard University who's studying ice-ocean interactions across scales from the subpolar North Atlantic to Greenland's glacier fjords. She uses observations from ship-based and moored instruments to understand exchanges of heat and fresh water in the ocean around East Greenland. And Kathleen Fuller is a high school biology and environmental science teacher at Milwaukie High School. She uses phenomenon-based concepts to engage students in the scientific process and develops lessons to integrate students' curiosities. Margaret, Kathleen, welcome. Now I'll turn it over to you to tell us all about your experience collecting water samples and servicing the moorings to monitor the North Atlantic currents.
Hi, thanks, Jamie. Thank you for that introduction.
Yeah. So we're currently on the bridge of the RV Neil Armstrong. The bridge is where the captain and the mates drive the ship, and there's a 360 view. So behind us is the ocean, but it might be very hard to see. So this is where we currently are and where we have been. So we started in Reykjavik, Iceland on July 26th, a very long time ago. And we've been at sea for 34 days now. Jamie, can you click on the slide? So we spent the vast majority of our time kind of within that red box, turning around moorings, which Margaret will talk more about because she's on the mooring team. And we also did a lot of CTD casts, which I'll talk about more. And we spent about 26 days off the coast of Greenland on both the east and west side, and took a couple days to transit through southern Greenland as well. And right now we're off the coast of Newfoundland. Click again. That's where we are. Yay. All right, next slide. So we're here as part of the OSNAP array, and OSNAP stands for Overturning in the Subpolar North Atlantic program, and it's a big international effort of lots of different teams and universities from various countries. And Margaret's team, as well as some others, are responsible for the moorings. If you click one more time, within this red circle. So those are what we serviced on this trip. We took them out of the water, cleaned them, scrubbed them, downloaded all the data, and put them back in the water. And now we're hopefully heading home soon.
And all of the arrows on here represent the current systems of the North Atlantic Ocean that make up this northern part of the large-scale overturning circulation. So the idea behind those moorings is that they should be monitoring some of the warm, salty currents coming from the south, so those are the red arrows, as well as changes in some of the colder, fresh currents coming from the north, which are the blue arrows. And we're trying to, as you see, monitor quite a complex and interconnected system here.
Great. You can click one more time. So this is kind of what I've been spending most of my time doing. I've been part of the CTD team. So CTD stands for conductivity, temperature, and depth. And it's this large instrument you can see in the middle of the screen that gets lowered up and down throughout the water column. I believe our longest cast was about 3,500 meters, which is over 2 miles underwater, which was pretty incredible. It took over an hour to descend towards the sea floor. This instrument can monitor lots of different data as it moves through the water column, primarily conductivity and temperature, as well as oxygen. And then in the rosette itself are big bottles that we can remotely close at target depths. And then once we bring them up, we have water from specific depths that we can then bottle and further analyze for a variety of different things. We have a lot of researchers on board that are taking water samples for a variety of reasons. Some are measuring what's called delta O18 isotopes, and they can, from there, ascertain where the water originated, which is pretty cool. I've been helping poison the water with mercuric chloride to make sure it doesn't grow anything funky while it's bottled for the next 6 months to a year before it can be analyzed back on shore for various dissolved inorganic substances such as carbon. And then this other picture was really cool. We got to see the solar eclipse off the coast of Greenland, but we still had to do a CTD cast while it was happening. So it was fun to have our little glasses on while we were doing water sampling. And Margaret can talk more about the moorings on the next slide.
So you saw some pictures kind of illustrating what these moorings look like underwater. Basically, we have strings with a number of different sensors at different depths that we leave in the ocean for 2 years at a time that monitor the temperature, the salinity, and the velocity of the ocean currents that are circulating around Greenland. And the goal here is to know how much heat and fresh water are being transported by the currents, how they're changing, and also to look at the gases like the oxygen and the carbon dioxide that are contained in the water, dissolved in the water, and how those might be sequestered at different depths and play a part in the large-scale climate as well. So it's quite a large operation to put some of these moorings down. As Kathleen said, in places the ocean is multiple miles deep, and so in order to build a string of instruments that's miles long on a ship that is not miles long, you have to gradually string out the instruments behind the ship as you go, and this can take hours and hours to do. So there's some pictures here on the left of kind of what that looks like. There's some large floats that are going to hold the instruments upright in the water that get strung out, again, for miles behind the ship as we gradually add more and more pieces to it. And this takes a huge team. It's one of the coolest parts of being on the ship is seeing the number of people that need to work together, need to communicate well, do everything really safely, because there is a lot of risk involved in basically working on the back of a ship in the open ocean with thousands of pounds of equipment. So you see everybody with their hard hats on. And then there's also a lot of work that happens in the lab to make sure that all of the sensors are ready to go in the ocean. So there's a photo of me and our colleague Jed sort of putting together some of the frames of instruments before they go in. There's a lot of programming that needs to happen. And even before we get out here, there's months and months of logistics and shipping. Also, the ship is rolling.
The ship just started moving.
So if you imagine doing those mooring operations on the back of the boat as you're in 4-meter swell, that's when things can get really interesting. Usually we don't work when the waves are that big. But yeah, so this is quite a huge operation that goes into getting these data. Could we go to the next slide, Jamie? So as Kathleen explained before, OSNAP is a huge international project, and we turned around 16 moorings on this cruise, which was a really big effort from the mooring crew in particular. The people working out on the back deck just put in many incredibly long days, back to back to back, while we had a good weather window to make this happen. We recovered hundreds of sensors. That's a picture of my colleague Allie scrubbing a conductivity and temperature, so salinity and temperature sensor that had come back. Every one of those sensors needs to be cleaned from all of the weird ocean goo that's grown on it over the 2 years, and then downloaded. And so from just one of the 16 moorings, here is what the temperature record might look like. You can see there's a lot of lines. They're very noisy. There's a lot of different, you can imagine there's a lot of different pieces of information that you could get out of this. And that's just from one mooring. We have this from 16 moorings from our cruise, a bunch of other cruises, and all of that we want to put together into something intelligible and useful to answer the big scientific questions that we're concerned with. So there's a huge number of people, huge amount of time and effort that goes into that. And Jamie, can we go to the next slide again? So there's a whole team that basically takes all of that data multiplied by all of the cruises and all of the moorings and works really hard on the data analysis back on land to put this together into something that can really provide insight into the overturning circulation that we are interested in. And that, again, is this large-scale system that brings heat from the tropics towards the poles and also brings poles from the freshwater from the poles towards the south. It's what keeps our winters in Europe more temperate. It's what has really set a lot of the large-scale climate in that we've grown to expect, basically, is based on this continual transport of heat towards the poles. And so after about 10 years of this, we've been able to put together this record of the overturning strength. And if you look at this and think, I don't know what this says, this looks just like a bunch of spikes, I think that actually is a little bit of what has been so interesting about this project, is that people talked about whether the currents might be weakening over time, and that might be happening. But when we looked at the 10-year record, we actually saw there's so much variability from year to year that helps us realize that there are many, many processes that control the variability of this part of the climate system. And so in some ways, the collection of this data has just opened up a lot more questions for us that can be really rich opportunities to understand our climate system better. But also shows us that in order to know whether there's a long-term trend, we need to have a much longer record to get beyond these year-to-year variations and see the whole picture. So when you see a picture like this that just looks like a bunch of squiggly lines, know that that's thousands and thousands and thousands of hours of people doing CTDs, etc. Cool. Shall we?
Next slide.
Next slide.
We've also had a lot of fun out here. One of my favorite things we got to do was take a cruise through southern Greenland in an area called Prince Christian Sound. There's a picture of Margaret and I in front of a glacier that we were able to see, as well as some other pictures. We've had some pretty epic sunsets. This sunset picture was taken at about midnight one night when we were still very far north and we were experiencing kind of that midnight sun. We've also seen the aurora a few times, which has been spectacular because I've never seen that before in my life. So it's also just been stunningly beautiful, this place of the world, and I'm definitely falling in love with it. Next slide. We also have had a lot of fun. We've been living on this ship for 41 days. So we've all tightly bonded, and I've absolutely loved every person I've worked with. So that top picture is some of us from the science team going into Prince Christian Sound. I hosted trivia for the science team, and a lot of the crew joined as well a couple of days ago to just fill a day. We did some cup shrinking at sunset, which was really fun. We've had some haircuts on board because, as I said, it's been over 5 weeks that we haven't been on land. You can click ahead one more. We've also done tons of craft projects, made friendship bracelets, embroidery, knitting. Margaret is not done with her blanket, but has made a lot more progress on it. We've played board games. We have Cheese 30 every day at 2:30. Our wonderful team of chefs and stewards set out cheese and crackers for us, which is always a highlight. We captured an iceberg one day, which was fantastic to watch and involved the whole ship. And that's a piece of iceberg that I'm holding there in the middle. And then that bottom picture is our current, right now, happening on the back deck. Our chief steward is out there barbecuing because our day is nice enough that he can be out there barbecuing. So it's been fun to live at sea for these 40 days. And I think those are all of our slides, Jamie. I can't remember.
Yeah, thank you. That was great. I loved the detail that you shared about the science and not only what it looks like collecting it currently, but some of the figures, the data, and how that looks after all of this time and years put together. So thank you for that and the fun photos as well. We'd like to ask some questions that we received from the Google form as well as what we've gotten in the chat during the talk. So folks, reminder at home or in the classroom, if you have questions for Kathleen and Margaret, please go ahead and share those. All right, so one question came in. This is for Kathleen. You mentioned the mercuric acid. Someone was wondering if you know, does that affect the water sample after reacting for so long as opposed to testing the sample immediately?
That might be a question I have to answer at a later date. From my understanding, these water samples are not analyzed on the boat. They have to be taken off the boat back to labs. So we're adding mercuric chloride to kill any living organisms within there so they don't grow weird funky things, but the dissolved chemicals remain the same within the sample, which is what they're analyzing for, non-biological materials.
Great. Yeah, thanks. Another question, a CTD question, Kathleen, while we're on that subject. Did you find anything in those bottles that was an unintentional catch? Did you, maybe a zooplankton?
There's probably zooplankton in there, but they're too small for us to see. We've closed bottles on salps, which look like jellyfish. So they're pretty gross to clean out, especially when they get caught in the lid. We've had to clean some jellyfish-like creatures out of the bottles.
Should we mention some of the other things that we've seen around the rosette, like whale poop?
I was not awake when the whale poop was seen, but yeah, there's whale poop.
All kinds of unexpected treats out here.
Nice.
Lots of birds, because I think we're going to feed them.
Yeah. A question came in about who is the ship's barber and what is their favorite haircut to do?
We'll shout out PhD candidate Kylie Kinney. She has been doing all kinds of haircuts. If you request it, she will do it for you. She's also doing hair braiding, anything you ask.
And she makes amazing friendship bracelets.
She does make really good friendship bracelets and good friends.
And good friends. And she's a great scientist.
Yeah, she's a great scientist she's at Scripps.
Oh, that's awesome. Sounds really fun. Okay, we have some questions about living at sea. So while we're on that topic, we can ask some of those. Let's see here. Someone asked, how big were the waves on your trip, and do they ever come over the bow? They also asked, and I'll answer this because I had to look it up, and you all might have too. So this person also asked, how much freeboard does the Neil Armstrong have? And for everyone at home, freeboard is the vertical distance from the water surface up to the edge of the main deck, and that's about 7 feet on the
We're
Neil Armstrong.
consulting with our chief mate right now who's off screen about how much freeboard we have. 5 feet.
Oh, 5. Okay. Google was wrong. Thank you.
The question was about waves.
Yeah. And have you seen any come over the deck?
Yes, we have. I got hit by one.
We saw one come over Kathleen.
One came over Kathleen while I was out on deck a couple nights ago. For the most part, we've been really lucky with the waves. Like, I, of course, have no frame of reference. This is my only cruise, but we've heard it's been really gorgeous. But at times, I think the highest I've seen is 4 meters or 13 feet. And that was a night that we were doing sampling and we were kind of getting thrown around, but we all have PFDs on, so we are kept safe. But I bent down to ratchet strap the CTD back onto the deck and a big wave came crashing over me. So that was very cold. But yeah, we've had some bow crashes, definitely.
We were really lucky. I think there was the cruise immediately previous to ours had much worse
A very hard
waves
crossing.
basically the entire time they were out. And it also impacts the operations a lot. You know, we can't do, like I said, those mooring operations with everybody out on the back deck are really not safe to do when you have such big waves. So we were super fortunate to have great weather.
Yeah.
Neither of us were really seasick.
Margaret and I both get very seasick very easily, so we've not been having a bad time, which is good.
And we were able to get all of our operations done with time to spare, which is amazing.
Oh, that's wonderful. That's great to hear. Okay, so another question came in too from the chat, asking, what was your favorite wildlife sighting, and do you see whales, and what kinds of whales?
Yes, we see whales. We are fortunate enough to have a marine mammal observer from NOAA on the ship with us, so he stands outside looking at whales all day long. We've seen a lot of whales. Just literally right before this live stream, Margaret and I were on the bow looking at 5 sperm whales that were popping up. I saw a pod of about 100 dolphins this morning. Let me look at my list of what I've seen. I wrote it down.
You saw orcas.
I saw orcas.
I remember that
I
you
saw
saw
baby orcas. We've seen a lot of pilot whales, fin whales, sei whales. Sei whales. I can't even read my own handwriting. Humpback whales, northern bottlenose whales, white-beaked dolphins, minkies, and our marine mammal observer saw a blue whale, but no one else saw it. Keep trying for that.
Nice. That and kelp.
And kelp. And a lot of birds. A lot of different kinds of birds.
Great. Let's see. Okay, so thinking about is there we understand you're monitoring the North Atlantic currents, but Margaret, do you have a very specific main scientific question that you're trying to answer?
So I specifically work more on the Greenland coast and less on the large-scale currents. And so what's really amazing about this project is that the things that we're measuring matter both for the large-scale climate and also a lot for some of the local dynamics and even the marine ecosystems on the coast of Greenland. And so it's amazing to be in this setting, in this group of scientists that are looking at the same currents in the same region, but from such different perspectives, and sort of to be able to bring all of that together. So for me, I'm really interested in the heat that's coming in from these Atlantic waters off of the coast of Greenland that also are very rich in nutrients, that are able to sort of reach the shelf of Greenland, the continental shelf, and get into some of the fjords where they interact with glaciers. And then the fresh water that comes from the glaciers comes back out into these same current systems and affects the flow of the currents. And so Kathleen mentioned the Delta O18 sampling that one of our team members is doing, that could be sort of fingerprinting which freshwater is coming from some of the glaciers that I might be studying, as well as which freshwater is coming straight out of the Arctic from the sea ice melting. And so this system of boundary currents really integrates all of those large-scale processes with some of the local processes. And it's a really rich experience to be able to work on that in this group of people who have such different perspectives on it.
Yeah, sounds one thing we hear time and time again is how much science involves collaboration all around.
And yeah, I mean, in so many different ways. Like we couldn't do anything that we're doing here without the crew who are supporting us in so many ways that I could try to list, but I think I'm not even aware of all of the ways that we're sort of being supported by them and by each other. And yeah, it's a really special experience.
Let's see. Here's a question kind of along the lines of the research topic. We had someone post a chat ahead of time. Bill, he was wondering what, and this I think can be for both of you. What is one thing you wish every person understood about these North Atlantic currents?
I think I'm understanding how much more nuanced and complex it is than I originally imagined. So I had to teach about this current system long ago for an environmental science course I taught. And so I think I had a really baseline understanding of it. But just working with this phenomenal team of scientists, I'm understanding how complex and nuanced it is, and that it impacts climate and climate impacts it. And it's just this back and forth that's so dynamic and kind of understood, but not fully understood, and it can be examined from so many different angles. So I think it's just fascinating for how overarching and complex it is what I wish everyone understood.
It's so awesome to hear you say that, because like for me to say what I wish people understood and to hear you say exactly that, it's a really nice moment. And I guess to maybe just build off of what Kathleen just said, when you read about these currents in the media, which I think we're hearing more and more about them, it's often a question of like, is the overturning circulation going to collapse? And I think just at the most basic level, we don't really, that's not really a defined concept, what it means for something to collapse. This isn't just, it's not something with an on and off switch. You saw that picture at the beginning. There's arrows going every which way. They're interacting with each other. They're interacting with the winds. They're interacting with all kinds of things we're only beginning to understand. Yeah. And so to talk about a collapse, I think misses a lot of, the impact of what's actually happening. And if we're always asking, is it collapsing? Is it not collapsing? We might be missing the actual changes that are happening. And it's a hard thing to figure out how to talk about, but hopefully we're getting better at it.
Yeah, definitely sounds a challenge when you talk about how nuanced it is and how complicated a system it is. We have Fiamma viewing. She was wondering when you were taking the CTD down to that really deep depth that you mentioned, Kathleen. Let's see, how fast do you lower it?
We lower at a rate of 60 meters per second until we start to approach the bottom, and then they slow down, because the worst thing that could happen is we inadvertently crash it into the sea floor.
Yeah, and that, it sounds like it might be fast, but it definitely ends up taking quite a while.
Several hours of watching a number get bigger on a screen.
And let's see, I think looking at another question. Kathleen, what was the most surprising part of this expedition for you?
I think the surprising part is just kind of how mentally taxing it can be. Margaret pointed out early on to me, you are literally living at work. Like, there is no boundary between work and personal life. And thankfully, I've really gotten along with everyone here, and I've had a fantastic group of people, and Margaret's phenomenal. So that was just kind of the most surprising thing for me of just how mentally challenging it would be. And then I think another thing was I have always taught with data in my classroom, but never had such a deep appreciation for what it means to collect that data, to watch literally hundreds of thousands of man hours going into recovering instruments and lowering CTD casts. I really, really like appreciate every dot on a graph that I will ever see for the rest of my life.
Oh, that's pretty awesome to hear. And Margaret, I'll ask the same question. I know that you've been out to sea before and on the same project out to sea before, but every trip at sea is different. And, this is the first time that you've been collaborating closely with an educator as well. So what's the most surprising part of this particular research cruise?
Well, I'm not surprised that Kathleen rocks, but Kathleen rocks. We can talk about it all, I don't know, every combination of people I'm around. Like, how great is Kathleen? She sounds great on the radio when she's operating the CTD.
My
That's
teacher voice.
Ooh, a good radio voice. That's cool.
I think I'm surprised every time I'm at sea. I don't know how much I enjoy it. I think not all the time. I think I get surprised by all of it, but just settling back into life on the ship and being with a group of people in some ways is really exhausting, and in other ways it is sort of like being at summer camp in a way that's kind of exciting. So I just always feel really lucky once again to be here with these people, and I also feel lucky to be going home soon. But
Excited to go home soon.
it's always special to see how the team emerges, how people come together to solve problems, and how people support each other. I think that's also one of my favorite things when you're with such an isolated group of people. Everybody steps up for each other in unexpected ways, and that's always really special to see.
I love the comparison with summer camp. I think that's a good kind of comparison. And then we had a question come in through the chat. I think this is more about the moorings than the CTD itself. So I'm going to give this to Margaret. How does the ship recover moorings that are stationed super deep in the ocean?
I should have totally included this. It's a really cool thing. So basically, the way that the moorings are constructed is that they have a very heavy anchor at the bottom, and they have floats at the top, and that holds the instruments upright in the water, as I sort of mentioned. But at the bottom, between the anchor and the instruments, there's an acoustic release, and so we're able to send a ping to that basically instrument at the bottom. When it hears this ping that tells it to unscrew, it will let go of the anchor, and that those floats at the top will pull everything back up to the top. And so basically it all just relies on a system. It's kind of like a sonar kind of thing. But so we're able to just call down to the instruments and say, okay, it's time to come back. And then they do, which is usually they do. We had this time one of the luckily relatively shallow moorings that did not let go when we asked it to. And so what we ended up doing was dragging for it, which basically involves putting some heavy weight down on the sea floor and trying to lasso the mooring and dislodge it from whatever it's stuck on. So once it gets knocked off, then the floats can pull it up to the top again. We've had a little bit of everything, but it's a really amazing construction. That all of the engineering that goes into making these things is really impressive.
I always think it's so interesting to have the visual of a mooring like in the dark at depth, like with alone, and then it hears the ping after years of being deep alone in the ocean.
There's something really poetic about it. Yeah. I agree. And it makes a beautiful little sound.
It does make a fun chirping sound. It talks back, which I really like too.
And then once that float hits the surface, I imagine that's kind of like a scavenger hunt for you all on deck, looking for that.
The few times I've been on watch when mooring operations have happened, the CTDs cannot happen while mooring operations are happening. So my whole watch is up on the bridge with several of the crew members, and we're standing all the way around looking for this teeny tiny yellow ball to pop up to the surface. And we usually have a pretty good idea which side of the ship it will pop up on. And then as soon as it's seen, the boat heads towards it and the recovery happens, which is also a pretty impressive process involving basically like a carabiner at the end of a stick, and they shoot it out there, grab it on, and then a team of like 8 people pull it backwards. They work it to the back of the boat, gets connected to the A-frame and brought back onto the boat, and then the 2 to 5 hour recovery process begins.
And we get our scrubbing gloves on.
The gross scrubbing gloves to scrub everything that's grown on it for the last 2 years off of it.
And then we had another question come in just now about do the moorings often stay close to their original site, or do you find that the currents are ever kind of drifting them a bit?
That's part of the engineering that goes into constructing these moorings in the first place. It's a great question, because if you don't put enough weight on them, or if there's too much drag on them, they can sort of get shifted around. And it is something, so basically, in short, they do stay where we put them, but that's because the people who designed them did a really good job. And the other thing is that the floats at the top do sort of get pushed down by the currents a lot. And so part of this is a little bit insider baseball, but part of the really fun data analysis is dealing with records where you've put an instrument that's meant to be measuring the properties at 100 meters, but it's actually sometimes getting knocked down to 500 meters, and figuring out how to reconstruct what the data should have looked like, or how to account for those gaps where you don't have measurements at the depth that you intended because the currents are simply too strong to hold your instruments in that spot.
Nice. Yeah, and I want to do a quick shout out to any math educators. This is an example of like finding these moorings when trigonometry is used. So
that's a really good. So when we first deploy them, we basically go to 3 different points. It's a perfect trigonometry question. Go to 3 different points around the mooring and send messages down to that acoustic release, very carefully not telling it to let go. But we can just say, hi, where are you? And it tells us how far away it is. And so if you go to 3 different points and find out how far away your mooring release is, then you can get, that's how we actually record the really precise location of where they've been deployed.
That's what I learned, because the GPS sensors don't work that deep in the ocean. So they have to do literal trigonometry to make sure they know where it is.
I think we have time for one more question. This is kind of a big one. This one came in earlier, but someone posted that they live in the Pacific Coast. This came from Banny, lives on the Pacific Coast, and is wondering, how does the cold water data you collect maybe connect back to our weather and El Nino?
It's a great question, because the climate system, as we've said, is really complex and really interconnected. To be able to make connections between our data and El Nino, I think, is hard with the timescales of the record that we have right now. There are people that do look into that a lot, especially with longer records or using climate models. And I think a lot of, we expect changes in the overturning circulation, absolutely, to have large-scale connections to global climate. So to be able to say exactly what those impacts are going to be is beyond what I can tell you right now. But I think there's some great studies looking into that, and hopefully with, we're able to extend our record here much longer, so that we can piece out some of the different drivers of the variability and the different timescales that things might be changing on. So I wish I had a more satisfying answer to that question. It's a really good one. It's all connected, but it's hard to say exactly how.
Yeah, definitely. Timescales make a difference, and trying to get the data to look into those larger timescale systems is an ever going challenge. And I just, before I say goodbye to you all, I did want to give a shout out that we heard that the RV sauna is watching. They wanted to know how much ice cream you all have eaten.
Hi guys, we miss you. We had I want to say it was a 5 gallon
I think we've had a
tub.
few of them.
Yeah, they're all gone. We don't have any ice cream left. Please send us some. We'll be eating all the ice cream in St. John's when we make it to Newfoundland.
Yeah. We do have about 20 people on this ship. It goes fast.
Was this a ship that you were in port with, or?
The sauna is right now, the sauna is a ship run by the Greenland Institute of Natural Resources, and our colleagues Fiamma and Aurora and
I didn't know that was the name of the
several others, hi Yanni, I don't know who else, are on that ship right now. So yeah, we miss you guys. Wish you were here.
Oh, fun. Nice. Well, we are out of time, unfortunately. Thank you, Margaret and Kathleen, for taking this time. I know there's busy science going on deck, so thank you for taking the time to meet with us, share your science, and answer these great questions. Please extend our thanks to the crew on board the research vessel Neil Armstrong for their technical assistance with this live stream. We understand that that everyone on board had to work together. They had to limit their internet use during this live stream to make it happen. And we appreciate everyone making those accommodations for this event. Thank you. And to you all, I hope that the rest of your fieldwork goes well and you continue to stay feeling great and the ocean cooperates with some smooth sailing.
Thanks so much. And thanks for sending Kathleen.
Thanks for
Oh, yes, yay. All right, and I'm gonna get back to sharing my screen again. To all of our viewers, I want to thank you all so much for joining us and asking such very insightful questions. There are so many ways to engage with Polar Steam. You can subscribe to this YouTube channel and follow us on social media at Polar Steam Team. You can see our blog, educational resources, and program information by checking out our website, and consider joining us at the Polar Steam Summit in Corvallis in October. As a reminder, that there is a recording of this live stream that will be available and posted on our YouTube channel. And thank you so much for tuning in to Polar Steam's Cool Connections today. And we hope to see you at our next one.